Okay, hi everyone. We're going to start in maybe 1 minute, just so that everyone's settled. Okay, so it's 6:02, so I guess we'll start with some brief introductions. So this event is part one of a machine learning series. So this event is actually an introduction to Python from scratch. So no need for any experience coding or coding with Python. So you're just here to learn Python from scratch. Don't let the terms machine learning intimidate you because this is just a prerequisite for machine learning. In this event, this is just Python. So if you're only interested in the Python, no worries, because here's where we're going to teach you all these things related to Python. And then if you're interested in machine learning, you can attend the rest of this series. So if you don't know me, my name is Hala. I am DSC lead for this year. I was selected by Google to be the SC lead for the academic year 2020-2021. Then a bunch of people were selected to be part of the core team. So Hadi, Sarah, and Peter are actually members from the core team. The core team is a group of people who help the DSC lead and work with running the club and preparing events and just making all this really cool content that we're giving you guys. So yeah, Peter, Sarah, and Hadi will be presenting this presentation, a complete introduction to Python for complete beginners. So just one quick note. Actually, let me move on to the next slide and then I'll say this. Okay, so you know the drill by now if you've seen any of our other events, but this is super important and I have to mention it. So we have a zero tolerance policy for harassment of any kind. Please do not ever comment foul stuff in the comment boxes. Please do not harass other audience members or harass members of the team. Please always remain at your best, and please always be excellent with each other and practice being positive to each other. So we are a very positive community. We are a strong community, and this is really important. This is one of Google's core values. Okay, so the next slide. Okay, so why are we having this machine learning series now? To be fair, we just started as a club. Maybe machine learning, why is it really our maybe first big technical thing that we jump right into? The reason that is because we have these monthly tracks. So if you've seen our info session, this will seem pretty familiar to you. But if you haven't, no worries, because I'm going to go over this super quickly. So what these tracks really are is, so Google selects these tracks for every month. For October, our track is machine learning. What does this track really mean? So we have the Quick Labs. So sorry about that. So the Quick Labs. Quick Labs is a website, just like Coursera, where you can take free courses, actually paid courses, um, that help you, learn new things on Google Cloud. Okay, but what you get as perks as a DSC member is you get a free month access to all of the Quick Labs courses every month, where you will be completing quests. So each quest is equivalent to one course, you could say, and each quest contains several labs. And then if you complete 5 quests in a month, you will get a reward. So rewards usually range from maybe a T-shirt with the Google logo on it, Google gift box, or even maybe Google Electronics such as Google Home. or a Google Home Mini, you could say. So if this is a bit ambiguous, no worries. So in the next slide, we have the list of all quests required for the machine learning track. So like I said, October is machine learning month. So we're having these events to inspire you to complete these tracks. So you have free access to Quick Labs. You have access to all these 5 quests. So each quest is a course. And then if you go and solve these or you finish these courses, you get these rewards. You also get some certifications for your LinkedIn. If you're already a member on our DSC platform, you should have received an email with how to get your free month for October as well as details about the tracks. If you're a new member, no worries, we'll send a follow-up email for this event for people who RSVP'd on the website, and we'll give you more details. For any other questions, you can always join our Slack and ask questions on the FAQ channel. So plenty of people are asking questions about Quick Labs. So yeah, so without further ado, let's just get started with the event. I'll let Peter introduce himself further and get started with the Python.
Okay, thank you, Hala. Hi, everyone. My name is Peter Saer. I am a fourth-year computer engineering student, and I am serving as part of the core team in this DSC year. So I'm here basically to help teach you introduce basically machine learning and start with the introduction of Python syntax and how it works. So before we get it started with Python, I wanted to start with a few slides about machine learning to sort of give maybe encouragement to why we're all doing this. So the expert definition of machine learning is a subfield of AI that provides methods to allow systems to automatically learn and improve from experience without being explicitly programmed. If you want me to translate that to English, it basically means that you write a little bit of code that allows a computer to learn without interaction from you at all. So you give it some data and it might find patterns, predict new outcomes, or many different other uses and uh, fields that machine learning can actually benefit. And actually, that brings me to the next slide. For those of you watching, just either scan this QR code or go to slido.com and put this number in. And I just want to hear your opinions. What fields do you think benefit from machine learning? I want to see how many you guys can think of, and I want to show you how many there really are. So whenever you're ready, I know there's a sort of delay, so we're going to wait here a bit, and we'll hopefully start seeing some answers soon.
Peter, while you wait for the answers, I just want to mention something real quick. So a bunch of questions are asking if they had issues accessing this month's Quick Labs. Yes, you're not the only people who did. There was an actual issue with the link. If you did it anywhere on the day I sent it, so I sent it yesterday, and if you did it anywhere during like midday, morning, or something like that, you probably would not have been able to access it due to an issue with the link from the DSC people. But I did contact them and we have fixed the link. So if you try again the exact same process, log into private browsing mode um, on your on your browser, and then just sign up and follow the steps, you'll definitely be able to get your free month. And if not, just always make sure to ask questions, and we're always ready to answer on our Slack or social media or email.
Okay, so yeah, now we're getting some good results actually. So all engineering fields, bio, economy, computer science, manufacturing, business, healthcare. Yeah, those are a lot of them. And actually, if you can think of any other field, exactly, medicine, robotics as well, um, all of these fields actually benefit from machine learning. So something as simple as healthcare or medicine benefit from it by maybe trying to predict whether a tumor is cancerous or not, or some actual financial institutions predict whether or not to perform some, I don't know, some trade on the stock exchange. And robotics is a big one, yes, because you basically want your robot to act normally, basically be aware of its surroundings. Yes, that does use machine learning, but to be fair, it's not as much as you think. The other one's actually much more common in robotics. Okay, so you guys probably got the hang of it. So let's move on. Now, what is Python then? Python is a high-level programming language intended for general-purpose scripting. It was first released in 1991, and it is considered an object-oriented programming language. So it's basically a programming language that, unlike others, is interpreted, which means the code you write is what is run directly. There's no middle step like others with compiling or whatever. So it is easier to run, basically. And a very nice thing about Python is its design philosophy, which emphasizes code readability. So their main point behind it was to being able to look at a piece of code and very simply understand what it does. And that move takes me to my next slide. Why use Python then? Well, first, as I said, the code is very simple to read and it's very understandable. And also, it is one of the most popular programming languages. Actually, it is the most popular programming language in 2020. Uh, and a main, basically, encouragement for us to use Python is because there are many simple to use libraries that allow us to implement machine learning models and algorithms. These libraries do all the heavy lifting for us. So all we have to do is write a few lines of code and we automatically get a regression algorithm or a, a classification model or whatever you want. And another great thing is that it is cross-platform. So the code you write on your computer will work on any other computer with Python installed. So where do you code then? You use, well, when you want to work with data science, a lot of people use what is called a Jupyter Notebook. It is basically an open source web app that allows the creation of documents called notebooks. They basically contain code, equations, and visualizations in sort of areas called cells. Each cell could have code that you can immediately run and immediately see the result of. So it is very easy when you're working with data to maybe manipulate it a bit and then immediately see the results of that manipulation. You could also draw it, graph it, or view a spectrogram if you're working with audio, for example, and immediately see all the results in front of you. And this does require you to have Python and Jupyter already installed on your laptops. But Google actually has a solution to that, and it's called Google Colab or Collaboratory. It is a Google-owned project based on the Jupyter project. It gives us all access to free notebooks that are hosted on the cloud, and it comes with all the libraries needed for machine learning already installed. It's a great way to play around with all the libraries and use them even for like professional standards without having to download or install anything on your own laptops. That being said, it is easy to download and install Python and Jupyter Labs. It's not very hard. At the end, we have a few slides to show you where you can learn how to do that as well. But for now, if you want, I believe we have a link in the description for a Google Colab notebook that sort of follows the structure of the presentation. And you can basically play around with the code after, of course, you make a copy of it. You can play around with the code and see how changes in the code affect the results. So before I move on, are there any questions now?
For now, there is no questions, so you can move on.
Okay, deal. So let's start with the basics of Python. So the building blocks of Python are the data that it runs with. Every small piece of data we can call a value in Python. It's basically every number or every piece of text, for example. Everything that a program works with, we can call a value. Each value has its own type. So a piece of text, which what we programmers call strings, they belong to the type str. Integers, or basically numbers, belong to the type int. Numbers with a decimal point belong to the type called float, or floating point value. And then we have other types like logical values, the true and false. Those belong to type Boolean, or BOOL. And just so you know, these are the very basic types. A lot of applications you can just get by just using these. But if you need to, you can create your own. and many libraries have their own types that you can use to make a lot of calculations or operations much easier for you. And the next big thing we need to talk about are variables. So variables, you can consider them like these, basically a cardboard box with a name on it. You can put whatever you want in this box, and whenever you call it by its name, you're basically referencing whatever value is stored inside it. So here we're creating three different variables. One is called message. It contains the string of text hello world. The second one is n. It contains the number or integer 20. And the third one is called pi. It contains most of pi. And just so you know that the type of the variable matches the type of the value it contains. Okay, so the type of message is the same as type of hello world, which is a string. And when you're naming your variables, you should consider that they can contain both letters and numbers, but they are not allowed to start with a number. And it is legal to use uppercase characters, but it is usually a good idea, and it's basically better practice in Python specifically to start variable names with a lowercase letter. And you can also use underscores. Usually we use this instead of spaces because you can't use spaces in the middle of a variable. So such as hello world, you can do hello underscore world, for example. And don't worry, Python will yell at you if you don't do it right, and it'll give you an invalid syntax error if you use an illegal variable name. And another thing to consider is that not all words can be used for variable names or identifiers. These words are called reserved words. They're called reserved because they are used somewhere else within the Python language for other uses, or yeah, for other uses basically. So those include true and false, like we saw before, because those are logical values, none, and, as, assert, and so on. Remember, you don't really have to memorize these. Basically, while you're writing your code, if you see a variable is always usually basically colored in white, and if you, while you're writing, see it turn into a different color, then it's probably a reserved word and you might not be able to use it. Okay, so assigning variables. To assign a value to a variable, you basically use the equals. And basically what happens is Python will look at the right hand of the statement. It will calculate the whole expression and then store the variable in, store the result in the variable name that you put on the left. And just so you know that you can update a variable after you set it. So if you look on the right hand of the slide, you see that we set x to 9.3 and then y to 10. Later on, you can set x to 2.2 and then y, and so x will be overridden and it will contain the most recent value of 2.2. And now let's look at the operators that you can use on different operands. So these are basically the math functions that Python has. You can do addition, subtraction, multiplication, division, power, and modulo. I'll talk about that one in a second. So what they do is basically you can use them with variables or direct values, and it'll give you the result. So if you're looking at this example, we set minute to be 59, and you can use a slash to divide it. So minute slash 60 is 59 divided by 60. The modulo operator is basically the remainder operator. So it returns the remainder of the division. So if you're looking at this example, as we said before, 18 slash 3 is 18 divided by 3. So that would result in a 6. There is no remainder in that division. So when you do 18 modulo 3, it will return a 0. And are there any questions, Hala?
Nothing yet. There is no questions.
Yeah, good. Okay. These are still the easy stuff, but we just need to make sure no one gets mixed up yet because it will get hard very quickly. Okay, so order of operations. It is in Python, the order of operations is very similar to math. So you start with parentheses, and then you go for power next. Then the priority goes to multiplication or division. and remainder, of course, and finally addition and subtraction. When there's a tie or like multiple operations, for example, 5 plus 2 plus 3, it'll go left to right. So it'll do 5 plus 2, get the result, and then add 3 to that result. And just so you know that you can convert from strings to other types. So before we do that, let me talk a bit about strings and their operators. You can use plus with strings, but it doesn't actually add them up. It performs concatenation, which means joining the strings by linking them end to end. So look, if you take a look at this example, in the first part, we're setting first and second to be the numbers 20 and 25. So when you do first plus second, you will get the answer 45. In the second example, we're setting first and second to the strings 10 and 160. So when you do first plus second, you get 10160 because it just smushed them together. They're characters, they're not numbers in this case. And another operator you can use is the multiplication operator. This will just repeat the string that many number of times. So it can only be done between a string and a number, an integer specifically. And you can convert between integer and floats by using the int and float built-in functions. We're going to be talking a lot about functions in the future, so just for your information, basically, for example, if you want to turn the number 22 into a float, you put it inside the parentheses and have float on the outside. And that'll basically tell Python you want to consider it as a floating point number, maybe for more precision or something in your calculations. Or you can do the opposite. If maybe you had a floating point number with a decimal at the end, you could remove the decimal part by turning it into an integer. You can also convert between numbers and strings. So if you had a string that basically was a number, like in the first example, you have 1, 2, 3, but it's actually a string of text, you can convert it to a number using int, like we saw before, or float. They both work here in this case. And finally, we have a few warnings we have to tell you. You can't add a string to a number. That will cause an error because they're two different types. You can either add two numbers or two strings, but not a number and a string. And finally, if you try to convert a string to a number, but the string actually contains no numbers, you will also get an error from Python. Anything, Hala?
No questions yet. Not.
Okay, awesome. And the last thing I want to talk about before I hand it over to Hadi is user input. Basically, some programs you might want to ask the user for some sort of input. Maybe you want to ask for a value or something. You can use the input function. And this will make Python give the user a sort of area to write their answer in. When they press enter, you will get that value and you can put it in your own variable and use it later on. And I guess I'll give it to Hadi now with comments.
So, hello guys. I'm Hadi. I'm a third year computer engineer, and let's continue. Okay, so now we're going to talk about comments. Usually,
Hadi,
after
before
yes,
I just,
yeah.
sorry to cut you off. Okay, so before we wrap up Peter's part, someone just asked a question. What if it has one number and the rest is letters? So Peter, you want to answer that?
Yeah, sure. So basically, if it has one number and the rest are letters, it will be considered as a string. So you have to keep that differentiation in mind. Uh, and like, if you see it as 1, 2, 3, it could be a string or it could be a number, depending on how you coded it. But if you have 1, 2, H, you can never convert that to a number.
All right.
Anything else?
Awesome, thank you. Okay,
Okay.
it's done.
Okay. So now we're going to talk about comments. Python ignores everything after a hashtag. So, for example, if we're writing a large piece of code and We want to just make sure that everything is not confusing and everything is clear for other programmers or for us later on. We just simply write some lines just to declare what we're doing here. Now we'll move on to comparison and logical operators. Let's start with Boolean expressions. For example, if we have, let's suppose, let's work with a simple one. First of all, we have 5 equal to 5. In this case, Python is going to compare these two numbers, and if they're equal, it will return true, otherwise it will return false. And true and false are special values that belong to the class bool or boolean, and they're not strings. We also have other comparison operators. For example, we have the equal to, as we said, the not equal to, less than or equal, greater than or equal. And it really depends on what you're doing and what you want to achieve in this code. So for example here, if we have a is equal to 10, we have a variable called a and a value of 10. We have also b, which is equal to 20. First of all, we're going to compare these two numbers. If a is equal to 10, it should return true. And in this case, a is not equal to 10, so we'll get false. Now we'll move on to logical operators. We have not, or, and. So for example, if we have x is equal to 5, and if we check if x is less than 10, Python should return true. Now, whenever we write not before this sentence, it should negate whatever we have after. So for example, here we have 5 is less than 10. It's right, it should return true. However, we have not, so it will return false. Now, let's check with the and. For example, x is greater than 0, 5 is greater than 0, so it should return true, and x is less than 10 at the same time, so true and true should return true. However, if we only have one condition that is satisfied, we'll not get true, we'll get false. And the same thing, let's work with or. X is less than 0, it's not the case. 5 is greater than 0, and 5 is not greater than 10, so we'll get false. And lastly, whatever we have with a true should return true. Now we'll move on to conditional statements. So anytime we have an if statement, it should be followed by a condition. For example, let's suppose we have a variable x, and we're going to check if x is greater than 0. We should print x is positive. And every time we write an if statement, the body of this statement should be indented. So it's not supposed to be at the same column as the if statement, as you can see in the slides. Now we also have the conditional execution. So for example, here, if we didn't indent, we'll get this error saying that unexpected indent. Now, sometimes we might want to run some code if a certain condition is satisfied and another code if otherwise. So for example, here we're going to check is x is even. We have the remainder character, as we can see. So for example, if x is equal to 4, let's say, 4 remainder of 2 is equal to 0. And in this case, it's correct, so we'll print x is even. Otherwise, for example, if we say 3, 3 remainder of 2 is 1, and it's not equal to 0, so we'll get x is odd. Now let's move on to chained conditionals. Here, for example, we're going to compare two variables, x and y, as we did before. So for example, we'll start with if x is less than y. In this case, we'll print x is less than y. Now, the abbreviation of elseif is elif. And we can use it here, for example, we can say that if else if x is greater than y, then we'll print that x is greater than y. And if this is not the case, then it surely is that x is equal to y. Now we have the nested conditionals. For example, first of all, let's check if x is equal to y, then we'll print equal. Otherwise, we'll enter another if statement inside this if-else statement. As we can see, they are nested. One if-else statement is inside the body of the other. So in this case, if x is not equal to y, then we'll check one more time. If x is less than y, we'll print less. Otherwise, we'll print greater. Now we'll move to catching exceptions. We have try and except in Python. So for example, let's suppose we want an input from the user and we're expecting it to be an integer. For example, we're asking the user to enter an age, and by mistake, the user typed some characters. So if we just convert this input into an integer, we'll get this error. So to deal with that, we can simply use try and except. Here, for example, we'll try to convert this integer in this variable into an integer. If anything happened or an error occurred, we'll just handle it using the except block and print please enter a number, since it is surely not a number. Now we'll move on to functions. We have some built-in functions in Java. For example, this is an example of a function type, and it returns whatever we have inside its argument. The type of this, for example, we have 45, and we know that 45 is a number of type integer, so it will return int. And we also have some other built-in functions in Python. We have the max, min, and length functions. For example, in the max function, we entered the hello world string, and it will search uh, through all the characters, and it will return the maximum character. And these characters are numbered from I don't know, 60 to some number. Uh, First, we have the upper cases, and then we have the lower cases. So this is why it returned W and not the capital H. And the same thing with minimum, and it happened to be that the space is the minimum, has the minimum number in Python. We also have the length, and in this case, we entered a string, so it will just give us the length of the string, and it is 11. Now let's move on to some math functions. For example, we have the ceil and floor functions. And in this case, if we entered, for example, 2.3, let's say, if we entered 2.3 inside the ceil function, it should return 3. And inside the floor function, it should return 2. We also have, for example, the factorial. It should return the factorial of any given number. And exponential, it returns the e to the power of whatever we have in the argument. Uh, we also have some other methods, power, as the name indicates, power x of y, square root of x, cosine, sine, tangent, degrees, and radians of any given degree, angle. Now, before we use this math, we need to import it by simply typing import math. And if we want to know some information about it, we simply print this math here. And here are some methods. For example, we use the math.log, math.py, math.sine, and math.square root. Now let's move on to random numbers. As we said in the math module, in the random module, we should import the random. And then, for example, uh, we can use this random module by assigning it to a variable. Here we have x is equal to random, and we use the dot operator to use the methods available for us in this module. And it happened to be that a random method is in this random module, And whenever we type this statement, we'll get any number between 0 and 1, but not including 1. So here we have some numbers. And for example, in this case, we have, let's suppose we need an integer and between two specific numbers. So we can simply write random.rand int and give it two values, 5 and 10. So it should return a number between 5 and 10 inclusive. And we also have another argument that is optional, indicating the step size. As we can see, random.randint 2, 10, 2. This indicates the step size of jumping on the random numbers. So for example, this can only return 2, 4, 6, 8, and 10. We also have, let's suppose we have S, and it is a sequence of 6 elements, and we need to choose a random element from the sequence. We can simply use the choice method and give it an argument of S, and it should return a random number. For example, if we want to get 2 random numbers or 3 random numbers, we simply add the additional arguments of 2 or 3 to get what we want. Now let's move on to creating our own functions. These are the previous ones were built-in Python functions. And let's suppose we need to create our own function. So the keyword is def. And in this case, we write the def and the name of our function, and we can give it some arguments or not. In this case, we didn't give any arguments inside the parentheses. And in this case, this function will only print DST club and AI club. For example, now, if we want to run this function, we simply type its name, in this case print clubs, and it will automatically print the DSC club and AI club. We also can use the function we created earlier inside another function. So let's suppose we have another function that is repeat clubs, and inside this function we use print clubs, the function we created earlier, 2 times. And let's move on now to fruitful and void functions. So when you call a fruitful function, you almost always want to do something with the result, and we need to use this result. As we can see here, for example, in this function, we have the area, which is math.py times radius square, and we can't use this temp we created, the variable we created in this function, outside of this function, since it is a local variable. We can't use it outside this function, so we should return this function. We should return this variable, and we can now use it outside. So for example, we create outside of this function a new variable called area, for example, and store whatever we have here inside this variable. Now let's move on to void functions. Sometimes we don't need to return anything. We simply want to print something on the screen or have some other effects. So we just simply use the void function. We don't return anything. We just work with whatever we have inside this function. For example, uh, print twice, and this is the function created earlier. It didn't return any value, and it will simply print DSC twice. And if, for example, we used this function name and print it, it will give us a none, which is in the class none type. Now let's move on to lists. And a list is a sequence. It can contain strings, floats, integers, or other lists. So for example, here we have house, which is a string, 5.0 float, 20 integer, and this is another list. And we indicate that this is a list by using the square brackets. So when we say that a list inside the list is a nested list. And for example, here we have three lists, fruits, numbers, and an empty list. If we want to print them, we simply type print and give it a parameter of fruits, number, empty, and we'll get the three lists we created earlier. Now, we have our list, so how can we access them? First of all, we have index of every element in this list. So for example, let's suppose we have the list called fruits, and in this case we have three elements in this list: apple, banana, and cherry. And in this case, we want to access banana, so we simply write the name of the list and followed by a square brackets, and inside this square bracket we just type the index of the element. In this case, we start with 0, 1, and 2, and in the negative index, we start with -1 in the last element and moving backward negatively. Now, how to add items? So we can use the append method. It is available for us in built in Python, and for example, we have three elements in this list and we want to add orange. So we simply write fruits.append, use the method append, and add whatever we want to add. Now, if we print it out, we'll get apple, banana, cherry, and orange. Now, sometimes we might want to add uh, this string or this element into a specific location, so we can use the insert method, and it takes two parameters. The first one is the index at which we want to add this element, and the second one is the element itself. Now let's move on to removing items. So as we can add, we can remove. And in this case, if we want to remove, we just simply use the remove method. And let's suppose we need to remove banana. We simply write fruits.remove and remove banana. We'll get apple and cherry. And we also have the pop method, and this method removes the last item if not specified. For example, here we have apple, banana, cherry. We'll get apple and banana. Now we also have the clear method. If we have, for example, 100 items or 100 elements in this list and we don't want to remove them one by one, we just want to empty the list, we simply use the clear method and it will return an empty list. Now let's move on to how to update items. For example, let's say we have a list of numbers 1, 2, 3, 4, and we need to multiply each number. So we simply type this numbers at x position, and the loops are after this. So you'll understand this for loop later. But for now, we can simply suppose that number at position x, and this is an index, a specific index. It can be 0, 1, 2, 3, 4, and so on. And every time we multiply this number by 2, so we'll get 2, 4, 6, 8, and 10. Now we also have some operations. For example, if we use the plus sign, we can concatenate two lists, and it is the same as extend, but let's say we want to add these two lists into a new list, an entirely different list. In this case, we'll create a variable called c, for example, and add a plus b. If we print c, we'll get a, b, c, 4, 5, 6. And however, if we use the extend method, we'll simply uh, add whatever we have in B to the list A. So if we go ahead and print A, we'll get A, B, C, 4, 5, 6, the same result, but in the first example, A and B did not change. They were the same, but we just created a new variable and give it these two lists. And also we have the star operator, and in this case we'll simply repeat whatever we have in the list the given number of times. So for example, if we have a 0 in this list, we'll simply multiply this 0 by 4, so we'll get 0 0 0 0, and 1 2 3 will get 1 2 3 1 2 3 and 1 2 3. So let's move on to sorting. We have the sort method, and it is built in Python. So we'll simply use it. For example, let's say we have a list of characters, and we use this sort method. We'll get this list, but sorted now. We also have some functions, for example, the length, max, minimum, sum, and in this case, we'll simply give it the parameter of the list itself. Here, for example, in this case, we have a list called nums, and it contains some numbers. If we use the length method, we'll get 6, since we have 6 elements in this list. The maximum will return 74, the minimum will return 3, and sum 154. And lastly, we computed the average, which is 25. So now let's move on to list and string. So to convert from a string to a list of characters, we can use the method list. In this case, for example, we have a string, which is Sarah. And if we wanna split up these characters inside the strings, we can use the list method. We simply give it a value of a string, and Python will automatically just divide this string into characters and store them inside a list. And for example, if we want to break a string of words, we can use the method split. So for example, here we have the s, which is a string, white is the new black, and if we use the split method, we'll get uh, a new list, and inside this list we have the words as elements. Now we also might to split, for example, let's say we have a specific character that we need to split on. We can use a delimiter, which is an optional argument that specify which character to use as word boundaries. For example, let's say we want to split hello world, so we use the delimiter as this minus, and we'll get a list of these two words as elements. Now we also have the join method, and this is the inverse of split, and it takes a list of strings and concatenates the elements. So for example, if we have white is the new black as elements inside the list T, we can use uh, delimiter.join. We can simply assign the value of a space to the delimiter, and it will simply merge these words into a string, and after each word it should put a delimiter, and it's in this case we have a space, so we'll get white is the new black. Now Sarah should continue now, so I'll leave
Hey,
it.
بس sorry before you go, بعد في a few questions they have. Hello.
Yes.
So
Sorry.
first question is, so the list is like an array.
Yeah, exactly. We can
Basically, I just want to add, arrays are usually, like in other programming languages, arrays are usually not dynamic like lists here. So here,
yeah,
lists you can change them, in other languages you can't. So that's it.
all right.
And someone asked could repeat void variables. I think they meant void functions.
Yeah. Can you return please, Peter?
Oh, hey, yeah. Okay.
This is the
There we
fruit.
go.
Okay. So here we have the void functions. It is a function just as the fruitful function. but instead we don't have a return value. For example, let's suppose you want to just print out something on the screen. You can use this function and don't return anything. Here we have, for example, the function print twice, and this print twice, let's suppose that it prints twice DSC. So we don't need to return any value. So we'll simply call it here, and it should return DSC twice. Now we don't need to even to store it in the variable called name. We can simply just call it print twice DSC. It should print DSC DSC. However, if for example in the fruitful function, uh, we can use it, for example, to compute the sum of a list. So whenever we need to use the sum of this list, we need to store it in a variable. And in this case, we should return this variable. Otherwise, we can't use it.
Yeah.
So
Okay, so basically, guys, in different words, as I come in, you did not understand that as well. Fruitful functions give you a value to use when you call them. Void functions are basically shortcut functions, so they let you do a lot of things just by calling the function. So they might do 100 different things, but all you have to do is call that one function and it'll do it all for you. But it might not actually give you a result. That's just it. Okay.
yeah, exactly.
Yeah. And I think that's it. I guess we'll go back to while loops.
Okay, thank you, Hadi. So Hadi mentioned lists and how we can work with lists. And one thing we could do with lists and other data structures that we're going to be seeing is loops. And so we'll begin by talking about while loops. And so, Peter, can you? So in a while loop, you should first start by writing the statement while, and then followed by a condition. And so this condition must contain a variable, and often we need to initialize that variable. So that variable should not just be entered immediately in that condition. It has to be initialized before we enter that while, sorry, that while. And so this is an example where we are going to print a variable n, and we're going to increment it each time we go through that loop. And so as you can see here, the output is that the n is being printed from 0 till 9. And when we finish that loop, we just print done. And it's important to say that we need to indent, so the body of the while loop must be indented. And so in while loops, we can use else statements. So let's say I want to print the variable count, and I want to print that that count is less than 5 when it's less than 5, and then print that this number is no longer less than 5. And so to do so, we can use an else statement. And each time we're going to increment that count by 1. And in that way, we can check that condition, count less than 5, each time we enter that loop. And so you should be careful when writing loops, not to enter infinite loops. So one way you could enter an infinite loop is by writing the true condition, and the true, it doesn't change, it's always true. And we're going to be seeing later how we can avoid having an infinite loop in such case. And an example is not updating your variable. So whenever you're writing, including a variable inside your condition, you must change that variable. And you can see in that second example that we did not change anything in A. And that caused our loop to be an infinite loop, because A is always going to be equal to 1. And so you should avoid that. And now we're going to be talking about the for loop, which is actually similar to the while loop. And so to write a for loop, we're going to, of course, start with the for, and then followed by, actually for loops are often done on sequences. So let's say we have a list, which you can see, which has the 3 elements, red, blue, and green. And so we're going to begin with writing a for loop, and we're going to say that for every element in that list, and so this element happens to be called color. It can be called any other name, but we decided to give it the name color. So for every color in that list called colors, we're going to print that color. And whenever we're done, we're just going to exit that loop. And strings are considered as sequences, so we can actually loop through them as well. So we've seen in the lists section with Hadi that um, we can then loop through sequences, and that's an example. And we've seen the range function. And so the range function gives us a range of values from 0 till the number excluding it. So let's say I want all the values of x in range 6. So x is going to be ranging from 0 till 5. So 6 is not included. And it doesn't have to be starting from 0. You can start it from 2 till 6, and again, 6 is not included. And of course, we can also add else in a for loop. So let's say I want to do something when my for loop ends. And to do so, we add an else statement. So for every x in that range, I'm going to print x. And whenever I'm finished, I'm just going to print finally finished. And we also have nested loops in for loops. So here we have two lists. And I want to loop through both lists. So for every element in my first list, I'm going to also go ahead and loop through every element in my second list. So you can see the output here. We looped first through red, and for red, I gave it the 3 values in the list fruits. So red apple, red banana, red cherry, and the same goes on for the next 2 elements. Any questions till now?
Nope, yet.
Okay. So we've mentioned previously that we can avoid having infinite loops. And one way to do that is by using these break, continue, and pass statements. So let's say we have this loop right here, and we want our user to keep on entering integers until he types in done. And in order to do so, we're going to first create a while true. So the condition is true. So we're going to be accepting input from the user until we add an if statement. So until that input is equal to done. So if that input is equal to done, we're going to add a break statement. So the break statement is going to let us exit that loop. So if the user entered that done, we're going to break from that loop. We also have the continue statement. And so for the continue, it does not exit the loop, which is the case in the break. It's going to skip all the code that is below it and just re-enter the loop. So for example, here we have this variable letter, which, this variable Python, which is a string. And I want to move on to every character in that string. However, I don't want to print the letter H. So I want to print all the characters in that string except H. And one way to do so is to add a continue statement. So if my letter happens to be H, I'm going to skip all the print statement and go on to the next character in my string. Finally, we have the pass statement. Well, actually, the pass statement actually does anything. It does not execute anything. So whether you add it or not, the output has no effect. So here, for example, if letter equal H, I'm just going to print that this is a pass block. However, let's say I remove pass, that output is going to stay the same. So the pass statement is often used whenever you're writing a program and you have a function that is
Sarah, we can't hear you anymore.
Yeah, it seems her internet. Um, cool. I will give her a minute. Do you want to continue this? Okay. Sarah, you're back?
Yes. Sorry for that.
No worries.
Okay. So as I was saying, past statements are often used when you have a function inside of a program that you'd like to add later. So you can't keep a function actually empty. So in order to avoid keeping it empty, you just add a past statement. And later on, whenever you decide to actually write that function, you can just remove that past statement and add whatever you want to add inside your function. So now we're going to move on to dictionaries, which are unordered data structures. So unlike lists, which have single items, dictionaries actually have key value pairs. So it has a key value it has a key and a value. And in order to create a dictionary, you first have to add a curly brackets, and inside of that curly brackets, you're going to add the key value pairs, and they are separated by a comma. So here we have the key brand and its value H&M, color, which is the key, and the value black. And if you'd like to print that dictionary, you'd be returned with the key value pairs separated with a comma. And in order to access one of these key value pairs, you just have to write the key inside of the square brackets. However, that is not actually good because sometimes we'd like to access something which is not found in our dictionary, and that would give us an error. So in order to avoid that, we can use the get method. And so the get method would get us the value of that key that we've specified. And if it's not value, we're going to add a default value for it to return for us. So for example, here we have a dictionary which has 3 key value pairs, and I'd like to access the key which is, I'd like to access the value which has the key tala. And if it's found, just return that value. And if it's not, I'm just going to return 0. And so it happens that I have a key which is named Tala, so it's returned for us 42. However, in the next case, we have a key which is Nibin, which is not found in our dictionary. So we are returned with 0. Now, dictionaries are actually mutable, so you can change values. However, you can't change the keys. You can change the values of the keys. So you can access the keys, but like we already said, so in between square brackets, we write the key and then we assign it a new value. And so here you can see that when we printed it, the value changed from black to blue. And we can also add items. So here we have this new item, this new key called price, which we do not have in our dictionary. So because we do not have it, it's going to be added as a new key value into our dictionary. And in order to remove items, we have several methods. One way is to use the pop method. So using the pop method, we just need to specify which key we want to remove. So here, let's say I want to remove the size. I just write size inside of my argument, and it's removed. We can also use the pop item, which removes the last inserted item. And we have other methods, the del, which is similar to the pop item. Similar to the pop, which removes the one we specify. And we have the clear method, which is similar to that we've seen in the lists, which clears our dictionary. And we can use dictionaries for many things, and one of them is using it as a set of counters. So let's say I want to count the frequency of each character in my string. And one way to do so is using dictionaries. So here's an example where first I have that string, and the first thing I need to do is create a dictionary, an empty dictionary, and then I'm going to add a for loop, which is going to let me access each character in my string. So for every character in Word, which is called C, if C is not in that dictionary, I'm going to add that character into my dictionary, and I'm going to add to it the value 1, as in saying that this character has been only repeated once in my word. However, if I do actually find that character inside of my dictionary, I'm just going to increment it. Now, on the right side, you can see that, sorry, on the left side, you can see that we added the if statement. However, to avoid using that and writing too much code, we can just use the get method that we've talked about previously. So I'm going to get that character inside of my dictionary. If it is found, I'm just going to increment it by 1. If it is not, I'm going to return 0 and add 1 to it, as it's been only repeated once till now. Any questions till now?
Yes, we have one. Can we write print finished without using else at the end of a while loop?
Yes, you don't need to use else while writing a while loop or even a for loop. I don't know if that answers your question.
I think that was it. Yani, you don't really need it, but it's there if you do.
Yes.
Okay, that's it.
Okay. Now we're going to reach our last data structure, which is tuples. So tuples are actually immutable, unlike lists and dictionaries. And in order to create a tuple, you need to have a list of comma-separated values. So here, for example, is a tuple T, which has these values A, B, C, D, E. So the moment I added these commas, this is considered as a tuple. However, we can just add parentheses. This is a known راحت الكلمة الشكل تبع التuples. So you can use both, but the one below is the one most known. Now, if you want to have a tuple of a single element, you have to use a comma, because if you do not use a comma, Python is actually going to consider this as a string. So in order to have it be considered as a tuple, we're going to be adding it as a comma. And you can see here we have the first example is of type tuple, and the second is of type str, referring to string. And we can also create tuples the same way we create dictionaries by adding this statement t equals to tuple, which is going to create for us an empty tuple. And we can add an argument, strings, or a string because it's considered as a sequence, or lists in order to create a tuple, and it's going to consider each item inside of that sequence as an element. So here we have an apple, which is a sequence of characters. Each character is considered as an element inside of our tuple. And so in order to access items, it's actually similar to that of lists. So the indices are numbered from 0. So if I want to access A, I just enter T and in between square brackets 0. And if I want to access the last item, I can just use negative indexing and write -1. So I have the last item. I can also use the slice operator to access more than one item. And so, as I've said, tuples are immutable. You cannot try to change any element inside of your tuple. But what you can do is try to create a new tuple and just add to it the new, let's say you want to change the first element. So you just add the first element, and of course, don't forget the comma, and just slice your tuple from 1. So that way you're removing the first element. However, you're adding, instead of it, the new element you want to add. So you can see at the output, we had that small a. However, now we have the uppercase A. However, that is a new tuple, not the same one. And Python actually allows us to assign more than one variable at a time when the right side is a sequence. So here, for example, we have x, comma y, which is considered as a tuple. And these x and y are considered as variables. However, the ones on the right are considered as values. So x is a variable which is going to take the value, which is the first element in our list, don't, and y is going to is a variable which is going to get the second value in our list, which is play. And finally, in tuples, we can actually compare two tuples to each other. And the way it goes is that Python is going to compare the first elements of both tuples. And if they are equal, it's going to go to the second element of each tuple. And if the second element of one of the tuples is greater, it's directly going to give us true. It's not going to go over all the elements of the tuple. And the tuple elements must be equal. So if I have on the right, at the left, a tuple of 3 elements, the one on the right must be also 3. And you can see at the second example, we have 0 and then 0, 1, then 3, and then 3. And you can see that it is actually greater, although we have a huge number at the third element. And so that's it concerning tuples. Does anyone has any questions?
No, nothing.
Okay, I think I'm going to leave the floor for you, Peter.
Okay, sure, thanks.
Thank you.
Okay, guys, so that was basically it. Sorry, I'm muting you. So these are some additional Python resources you guys can look at. We're, of course, going to give you the slides, I believe, in the follow-up email. And you can have a look at these links and check them out for yourself. They are very good resources to learn on your own, and they're very hands-on. And of course, we wanted to let you know that this is only our first part of our machine learning series. Next Friday is our next one, where you're going to learn NumPy, Pandas, SciPy, and Matplotlib, Friday at 6 p.m. as well. And the Friday after that, hopefully, will be our learning basic machine learning with TensorFlow. And we know it wasn't very hands-on, so if you guys have any questions, please ask them in the chat. But in the meanwhile, I'm going to be showing you what the Collab notebook looks like, so you guys can play around with it in case you want to. Okay, so this is Google Colab. I don't know if you guys can see it very well on YouTube. Yeah, let me zoom in. Maybe that'll help. Basically, it is a huge, it's this huge platform where you can write your own notes and write code as well, and then immediately see the results right after it. So this is the one we prepared for this presentation, and it basically follows the order of how we talked about all the different parts of Python. So to run any one of them, all you have to do is press the play button next to a cell and hit run anyway. It'll take a while the first time because you're connecting basically to your cloud instance. And right then, and as soon as it's done, it'll give you the full output. Of course, you can change anything you want in the code, and just press play again or control enter, and it will run it for you. So that's basically how you do it. Just a side note, you have to copy it to your Google Drive because this is a read-only copy. You can't actually save any changes you make. So be sure, guys, to play around with it, get the hang of it, look through the slides again, and yeah. And I see a question if we're going to send reminders about the events. Yes, of course we are. You will probably get them sometime next week as well. So I think that's basically it. Hala, you want to add anything?
Yeah, I just wanted to add that the copy to drive button you see right there, so you might not have actually access to editing the notebook since this is the same one for everyone. So just copy it to your drive, then you can access it at any time from your Google Drive and run stuff and just really, code and all that. So it should be pretty self-explanatory. Yes, there will be a follow-up email with these slides, as well as a link to the recording, as well as a link to the notebook as well. Also, I will be resharing the document related to Quick Labs and how to get your free month, as well as the tracks for this month. Okay, so yeah. Another thing I want to add, okay, just before we wrap up, is anyone who is signed up on the DSC platform, you will receive this follow-up email. And then if you're not, then there's really no way for me to be able to get your email and email you everything. Okay, so make sure to sign up on our platform. If you don't know how, check out our Instagram, DSCLAUB Plus. The username is DSCLAUB Plus, and then you'll find out how to sign up on the platform. Once you sign up, you get all the emails, all the event reminders, and pretty much anything. So that's your sure way to go. Okay, and yeah, that's it from my end. Cool. So we're done. Peter, anything else?
No, I'm good.
All right. So thank you very much for everyone who attended. Thank you for signing up on the website for this event, as well as for joining us. And we're really happy that we hope you were able to benefit from this event, and we're happy that you joined. And if you did feel like you benefited and you want to take that a step further and go the way to machine learning, join us next week at 6 p.m. Actually, I did get receive some feedback that a lot of people had labs, so maybe we'll push it to 7 p.m. So you'll get reminders and announcements concerning everything. Okay, so thank you very much again. That's it. We can stop the stream.